My name is Tripp Nelson with Alexseal Yacht Coatings. Just to give you a little bit of history on Alexseal, we are a brand owned by a German paint company called Mankiewicz Coatings. And Mankiewicz is a privately owned paint company in Hamburg, Germany, also Charleston, South Carolina. We have a facility. It's over 100 years old. What we're going to go over today is basically this presentation is going to be sort of an overview of coatings. We can get as detailed as you'd like with your questions, but we're going to talk about the history of yacht coatings, trends in coatings, and basically trends in coatings will include everything from a little bit of color trend to some of the special effects you see today with metallics, pearlescence, things like that, and assessing the project and choosing the right coating. One of the things that we're always approached with is with regards to scheduling, controlling customers' expectations, meeting customers' expectations with a project, and basically that can all start from the very beginning of the project and assessing it properly and choosing the right coating system. And then we're going to touch base on care and maintenance, because at the end of the day, the coating and the exterior look of the vessel is all based on care and maintenance. We see paint jobs that can be ruined very quickly by using the wrong products on the boats, and we see paint jobs that last for many years and look very good. And since you're all, for the most part, selling yachts and you're selling the lifestyle, you all know that when you're presenting the boat to a potential client, first thing they see is the exterior of the vessel. I mean, and of course, the exterior of the vessel doesn't control whether they can use the vessel or not, but there's a perception. If the boat doesn't look good, you kind of wonder what's on the inside. If the boat looks good on the outside, you feel better about what's on the inside. And then we're going to have a quick summary. Starting off with the history of yacht coatings, basically I didn't see too much point in going back beyond like 1960. Back in the 1960s, boats were painted with alkyd enamels. Alkyd enamels are single-part paints. They're basically air-dried. They cure with a reaction to the air. And what you'll see with an alkyd enamel is over time they get chalky. That's because they continue to cure when they're exposed to air. Some alkyd enamels are still used today, like for instance, on a plank-on-frame boat, alkyd enamels tend to breathe a lot. So if you do have a plank-on-frame boat, an alkyd enamel is the best thing you can put on there because it will allow moisture to come and go through the coating. With a polyurethane paint, like what most of the boats are painted with, you basically encapsulate the boat in a piece of plastic, which doesn't allow moisture to come and go through the film. So we started out in the industry with alkyd enamels. The first boat that was painted with a polyurethane paint, two-part polyurethane paint, was in 1973. This boat was painted here in Florida, and the first boat with a polyurethane paint was painted with all grip. Many of you might know the history of all grip. It started out as a product called Alumagrip, which was a paint that was used at McDonnell Douglas. McDonnell Douglas needed a paint that could withstand aviation hydraulic fluid called Skydrol, and the only thing they could find to withstand this harsh chemical was a two-part polyurethane. Well, they used a two-part polyurethane on the aircraft, and then some guys said, well, if it works on the plane, why can't I use it on my boat? And still today, that's very common because our company, Mankiewicz, as well as other paint companies, supply to the aircraft industry. Today, we sell to Boeing, we sell to Airbus, we sell to Embraer, and we take that technology from aircraft and we modify it and we put it on a boat. We can't take the exact same formula because if you look at a commercial aircraft, it's basically riveted aluminum. Well, if you take that paint and you spray it at aircraft, you want the paint to cling to the rivet head. You don't want it to run off the rivet head. Well, that ability to cling to a rivet head on an airplane creates orange peel on a boat. So we take the same resins that we supply to the aircraft, but then we modify them, get them to flow a little better. So the first boat was painted with two-part polyurethane in 1973, and then in the 80s, the polyurethane use on boats really took off. More and more boats were being painted with polyurethane. They were painted with different types of urethane. And we'll get into that in a minute, the difference between aircraft-style polyurethanes and automotives. The market grew, but then it started to sort of stagnate. In 1994, there started to be a lot of use of automotive paints on boats. And in 1994, U.S. Paint, which at that time owned Allgrip, they were the prominent player in the marine market. They introduced a product called Allcraft 2000. And Allcraft 2000 was an acrylic urethane. It was dried quickly. It was easy to apply. And that was in 1994. They introduced that. And then in 2002, U.S. Paint sold Allgrip. And where I'm leading up to this is after 2002, Alexseal was introduced in 2004. And after 2004, we started to introduce the product globally. And today, Alexseal is the #2 brand in the market. In 2010, what you started to see was a lot of metallics and special effects on boats. Up until this point, primarily you saw white finishes on boats, flag blue, jade mist green, things like that. But in a nutshell, this is sort of the history of the coatings that we've seen. I wanted to put this up there because boats like this are still out there. Nitwits from 1960, other boats that were introduced in the 60s, 70s, 80s are still out there afloat. And what we've found is that as we're applying today's coatings over the existing coatings that are on some of these boats, you have to be very careful about compatibility. And as you're selling boats that are potentially older or have existing finishes on there, you need to be aware that sometimes the solvents in today's coatings can negatively affect the older finishes there. But boats like this, many of you are aware of these, and they still exist. So,
what I want to talk about first is the trends in colors. Over the time, obviously you can see even on our color card, there are some whites, and I don't want to say whites are becoming a dinosaur, but whites are starting to be moved out a little bit by the darker colors, the darker blues, the grays, and obviously now the metallics. And what we found was that this trend usually comes from the automobile industry. So it usually lags about 5 to 7 years behind the auto industry. So if you think back about 5, 7 years ago, there were more blue cars, there were more metallic cars, there were more gray cars, and now we're starting to see that in boats. So this trend, let's switch to the next one. This trend is obviously changing over time, and it's only going to get worse, or not worse. It's going to only get more difficult, as the next slide will show you.
Yes. And one thing about color is most of you are all aware that a dark color absorbs the ultraviolet light, which absorbs heat. Okay. Dark color is obviously always more warm than a white color, than a pastel. That leads to heating up of the surface. That leads to post-curing of the fairing materials. We've actually seen it lead into movement in the substrates of aluminum and steel. So as yachts are getting more colorful, everybody needs to be aware that if you take a boat that's painted white, and it's a 20-year-old boat, and you paint it a dark color, it still can show print through. So if you have an owner that is buying a boat from you now and it's white and they want you to change it to flag blue, that flag blue is going to generate a lot more surface heat, and it potentially could show some print through on there.
Yeah, and I know firsthand on this. We did a science experiment with my kids. The whites usually average in the mid-90s for temperature, while a flag blue is going to be about 190, almost 200 degrees. So I mean, that's a heck of a different temperature difference.
Superjet black, we've measured up to 220 degrees Fahrenheit. And what you'll see on a lot of the boats these days is on a sport fish, you put a metallic windshield on the front of the sport fish. Well, the reason the metallic's in there is it actually reduces the surface temperature by about 20%. So a metallic windshield on a sport fish might get up to about 180 degrees Fahrenheit, whereas a straight Superjet black windshield might get up to 220. Well, that makes a big difference inside the cabin. On the back side of that windshield, usually where the electronics are stored and other things. So it is very important to know that although yachts are getting more colorful, there are some downsides to this color, and typically that's a heat absorption.
This is what I was talking about. Who knows? This could be the next color combination that we're going to see out there. Another trend, and obviously with yachts, is that they're getting larger. And in paint, that means you're going to have more chutes versus just one or two chutes. You have to have more chutes to get the surfaces covered, which is going to obviously make you have more tape lines, which is something we have to deal with. Also, you're going to have multiple applicators. I've been on a shoot where we've had 4 applicators at one time, and Tripp's been on one where they had 7 people shooting at one time. So you're getting 7 people trying to get the exact same finish out of the gun at the same time. It's rather difficult to do. So that's a challenge for us as a paint company. Also, what needs to be done with these larger boats is that the fairing, along with the color, obviously, the fairing needs to be a lot more flexible than it has been in the past, because the larger boats, they don't have any expansion gaps, so the expansion and contraction can't happen. It's going to have to happen in the fairing compound. So the fairing compound has to be a lot more flexible than it has been in the past, especially with the darker colors.
Yeah, with dark colors, as we mentioned, you generate heat, but also these boats are going through cold cycles. And as you go through the heat and cold cycle with the fairing compounds, and with the substrate, the steel, aluminum substrate, with a typical boat this size, you do have this expansion and contraction. And as Jeff said, you need more and more flexibility. And the builders have to pay attention to how much fairing they're putting on, because they put on quite a bit. In this case right here, this boat, Yaz, she was a destroyer that was actually taken. She was cut in half. The superstructure was taken off of it. She was extended and then completed and all faired out. Just one example of how you mentioned earlier about a boat that was cut in the middle and extended. There's a tremendous amount of fairing compound on these boats. Now, from a paint manufacturer standpoint, it's not too much fairing compound as long as it's applied right. But it does lead into the fact that we need more flexibility with boats that are getting up to 180 meters now. And that's something that we've been developing. A lot of companies have been spending a lot of R&D on. I think you'll see more and more information about new fairing compounds that are more flexible.
Obviously, with the yachts, the geometries are changing, which again leads to more tape lines, things that we have to that have to be dealt with. That the owners don't like to see tape lines, and also going back to the fairing again, you need to have the flexible fairing.
Yeah, if you're dealing with a owner that basically has an aversion to tape lines, and basically you have a choice with tape lines. You can either leave them in, or you can sand them out and buff them out. If you sand them out and buff them out, there is a chance that you'll see them later on. So we see more and more where we'll leave the tape lines in and have more breaks, but as the boats are getting more complicated, the geometries are getting more complicated, it does become more difficult to figure out how to paint the boat in the section that you don't have to have tape lines.
And obviously one of the things that's changing with the darker colors, metallics are becoming more popular. Obviously metallics, they look great, but they are very hard to touch up, and we try to tell everybody before they decide to go this route that touch-ups could be a concern.
The largest boat that we've supplied metallic paint to so far is 300 feet, and they are becoming more popular. One of the things we do as a paint manufacturer is if a customer comes to us at the boat show and they want to paint their boat metallic, we tell them that the metallic is not repairable. Now, there are applicators out there that might be able to do a satisfactory repair, but they're few and far between. And we feel that it's best to control everybody's expectation by saying the metallics are not repairable. That way, they're not going to be disappointed. The owners aren't going to be disappointed. The captain and crew are not going to be disappointed.
And another thing is you can have multiple applicators on the Sumat here. There was 3 guys spraying, and with different applicators, each applicator is going to apply it a little bit differently, so the metal flake can, when it dries, it could be a little bit different too. So you can maybe see some differences in the metal flake with different applicators.
What we do with our metallics when we produce a batch, it doesn't matter if we make metallic paint, white paint, doesn't matter what it is. Every time we produce a batch of 1 gallon or 1,000 gallons, we actually have somebody spray it out, they dry the paint, and then they check it on a color computer for color accuracy. With the metallics, you can have so much variation. We have a robot spray every batch that we produce. With a metallic, the distance between the spray gun and the surface, if that varies, your color on your metallic can vary. We've found that air pressure can change the color of a metallic. And the reason is a metallic is a paint with an aluminum metal flake particle in it. As that metal flake dries, it basically has an orientation. That little piece of metal might be 90 degrees to the surface, might be 45 degrees to the surface. When you go back and you do a second application of a metallic, it's almost impossible to duplicate the way it dried. And that's why with a metallic, it's difficult to repair it. You might get a good repair from straight on the surface, but from an angle of 45 degrees or 60 degrees, you see a different color. And again, that's why we tell people that they're very difficult to repair.
Again, metallics bring different challenges. Also, we're starting to see trends for flat finishes, which will look great, but then again, when the fenders rub up against them, it's going to polish the surface a little bit, and you're going to have a polished surface.
We talked a little bit about metallics. We've talked about some of the downsides to flat finishes there. One of the things we want to talk about is assessing the project before it gets painted. And this is important because you've got to identify if you can meet everyone's expectations. When you're assessing the project, you need to identify what's the purpose of the project. Is it a new build? Is it repair? Is it refinish? What's the level of finish that's achievable under the conditions and the schedule? You know, the thing about paint is paint's always done at the end of the refit. It's always done at the end of the new construction. So if the welders or the electricians or mechanical took longer than expected, then the delivery date doesn't change, but the paint time gets condensed. So a lot of times the intention with a paint job is to do what we call a show coat, where you might apply top coat to the boat, sand that out, and put a final top coat over it. Well, if you're running out of time, you can't do that. So you need to agree on what the level of finish is, and is it achievable under the conditions in the schedule. The other thing that is done quite often these days, and we definitely encourage it, is to have a sample panel sprayed by the yard so that there's an understanding of what the level of finish is. What's the level of orange peel, dirt inclusions, and gloss. And that way there's not going to be any miscommunication at the end of the spray job. And identify what areas of the project are most critical. A lot of builders these days will do an A, B, and C area. A being the most critical, where the owner boards the boat, where they spend time. C being the hull, where people aren't going to see it except for the crew. And when you're accepting a paint job, it's very important to identify what the A, B, C areas are, or at least have some understanding that there's certain parts of the boat that are more important than others to be dust-free and orange peel-free. When we're assessing the project, this is a few examples that are important. You know, a lot of the times you might be selling a boat and it's a used boat and it's got some blisters or some corrosion occurring. Well, if you see a visible sign of corrosion like this, chances are it's spread much further than that. You know, underneath the urethane finish, corrosion will creep and you won't be able to see where it occurs, but in a repair like this, there's going to have to be additional work done in this joint and further on, probably on the back side here. And so you can't just judge the affected area. If you see a blister on a boat, then chances are that the affected area is much broader than the blister that you see. And that's, again, part of assessing the project. There's some very good surveyors out there that you can bring in. Also, some paint companies will also look at the situation if you need it. One of the other things that we've seen a lot is this is an example of an older boat, 30-year-old boat that has a lot of corrosion. And this particular boat is one where when the project started, the corrosion wasn't identified properly. And then it just grew, and sometimes that will lead to expectations not being met.
What we want to talk about now is the different coatings that go onto the boat itself. We're going to start with protective primers and go all the way up to the top coat itself, and Tripp will tell you about the different top coats that they have. The protective primers, there's two different primers categories. One is they're both anti-corrosive, but one is a passive and one is an active anti-corrosive primer. With the passive anti-corrosive primer, all you're doing is you're covering the surface, and that basically is your anti-corrosive protection. So if you get a scratch in it, it will creep, like Tripp said before. You'll have some creeping, and you'll actually have a lot more creeping than you would if you go with the active process. The active process is a strontium chromate that you put down first. And what that does is if you scratch it and you go down to the metal, the chromate will help stop the creepage, which is very important, and it will make the repair a lot easier. Most people will go with the active and then put a passive on top of it, so you have two layers. The next one is fairing compounds. Obviously, we talked about the fairing compounds. They're always epoxy-based, or usually epoxy-based. On the large vessels nowadays, they're putting a lot of fairing compound on these things, and they really do need to be a lot more flexible. Real flexible, versus back 30 years ago, they were less flexible and they had some cracking. Then we have the two next ones are the high build surfacers, are basically products that just, what we're doing is you want to have a hard product. The high build surface is a hard product that kind of closes in the fairing compound, and then you want to go with a softer primer, that's the finish primer that you go on top of that.
Jeff mentioned is the strontium chromate primer that we sell to the marine market. And it's that very thin yellow-green primer that you've probably seen for many years. But it is the best thing you can put on any type of aluminum, be it on an aluminum hull, if you're doing blister repair, or a sailboat mast, or T-top, anything like that. So make sure that if you are doing a project, you've got customers asking about what type of system to go on aluminum, you want to try and use a chromate primer if you can. And some people believe that chromates are banned. They are not. It is a heavy metal, but you're not sanding it. It is definitely available. The aviation industry uses chromates every day, and they haven't figured out a better way to protect the aircraft, so they're not going to get rid of it.
This part here is very exciting. I know. You can take this home, and over the weekend while you're painting, using your Home Depot, you can say, "Hey, honey, I learned this in school," or the other day, because all paints are basically about the same thing. You're going to have the four different items. You have pigments, which is the color. You're going to have binders, which is going to be either latex for your Home Depot Bear products, or you can have epoxies, or you can have urethanes. You can have additives inside of that also. And those additives obviously are flow agents, anti-foaming agents. You're going to have the UV packages for urethanes. And then also you have the solvent, which is always going to be the vehicle that gets the paint out to either the boat or your wall or whatever else you're painting. That's the four things that are basically in paint. So you can go home and say, "Hey, honey, I learned this while you're painting this weekend." It's exciting. That's exciting right there.
It is exciting. And there's two different primary types of paint you could also tell them you learned about. Waterborne paint, or water-based, and solvent-based. Okay. We manufacture both types of paint. We manufacture a lot of waterborne technology, and we sell it to industries that can control their application conditions. Then we sell a lot of solvent-based paint, and we sell that to industries that can't sometimes control their application conditions. And basically, you work in an industry that cannot control their application conditions very well. With a water-based paint, you're waiting for the paint to dry for the water to evaporate out of it. If you've ever painted your living room on a day that's raining, you'll notice that your latex Home Depot paint doesn't dry very quickly because you're waiting for that evaporation effect of water to come out of the coating. Well, companies like BMW that we sell to for interior coatings, they can use a water-based paint because they have spray booths and climate-controlled conditions where they can pull that water out of the coating quickly and efficiently. When we're painting a yacht next to the water and we have no climate-controlled conditions, we're in a tent, basically we can't control the evaporation rate of the water very well, so we use a solvent-based coating. The solvent-based coatings, we have got a lot of flexibility there because we use solvents that evaporate very quickly, like acetone. You're all probably familiar with acetone or MEK. And we also use solvents that dry very slowly, like toluene or xylene, or like a lighter fluid. And we'll use a blend of these different solvents to control the evaporation rate of the paint. So at the end of the day, we might use the same pigments in our paint, whether it's water-based or solvent-based, but we use different vehicles and to cure the paint and dry the paint. One of the things we wanted to go over that we see a lot of confusion about in the marine market is the differences in polyester-based polyurethanes and acrylic-based polyurethanes. Aliphatic polyester-based polyurethanes, also sometimes called linear polyurethanes, come from the aircraft industry. This is the original type of All Grip, Sterling, Jet Glow, Alexseal. Those are all brands that fall into the polyester-based polyurethane market. They came from the aircraft industry. They're very durable, scratch-resistant, and chemical-resistant. You can pour acetone on a polyester-based polyurethane, and it won't hurt it. It's designed to resist antifreeze and various things like that. It's designed to be flown at 30,000 feet, 500 miles an hour. The acrylic-based polyurethanes come from the automotive industry. They tend to be faster dry. Faster dry is when you're applying it. Sometimes easier to apply. They tend to be a little softer, and when I say softer, you'll see fender wear more often with an acrylic-based polyurethane. But being softer, they're easier to buff. So if you want something repairable, the acrylic-based polyurethanes tend to be easier to repair. So what you'll find in the marine market is a lot of applicators will choose a coating by what's easier to apply or easier to repair, but that doesn't always mean that it's the most durable coating. For instance, if you want something on your non-skid that's going to be as hard as possible that you could put on the cockpit of a sportfish boat and drag a cooler across, you want the hardest paint you can get. You don't care if it's repairable necessarily. You want it to be scratch resistant. So in that case, you definitely go for a polyester-based polyurethane. If you want something that you know you're going to do a lot of spot repairs on, and you have to wet sand and buff out the side of the hull because the owner wants a flawless finish, then you may choose an acrylic-based polyurethane. But there's definitely two different types of technology out there. The acrylics tend to be the DuPont Imron, the Allcraft 2000, Acroglow, BASF. There's a lot of good brands out there, been around for a long time, but two different types of technology. The polyester-based polyurethanes are the ones that are brushable. Okay, so we can take a isocyanate hardener and we can make it sprayable, we can make it brushable. The acrylics are not brushable, they're just spray only. So if you want something that the crew can touch up by brush, the polyester-based polyurethanes are the way to go. And as the boats get larger, they typically always go with the polyester-based. There's a lot of impact from a polyball or a fender that's pressing up against the hull, and that impact creates a lot of abrasion. And on the acrylic-based polyurethanes, you'll see that. They tend to show up quite a bit. The other thing that's there's a lot of misinformation about when it comes to polyurethanes is repairability with a solid coating, not metallics. We talked about metallics earlier, but I'm talking about Matterhorn white, cloud white, flag blue, things like that. The uniform curing of the pigment and resin equals repairability, or helps with repairability. What I mean by that is there are paints out there that basically when they dry, there's a clear resin on the top. Well, our paint and others that are easier to repair have the pigment throughout the whole coating. And the reason that's very important is if you can imagine you've got a painted hull and you have to do a repair, well, you have to blend new paint into old paint. And there's a bevel there, a scarf, where there's a transition between the old paint into the new paint. If the pigment in that coating is uniform all the way through, when you buff it, you don't get a halo. You won't have that circle around the coating. So that's why some coatings are more repairable than others, is you basically have the pigment going all the way through the finish. And if anybody ever tells you that you can't do that, ask them if they've ever sanded paint. Because as soon as you put sandpaper on paint and you start sanding it, with a paint like ours, if it's a flag blue boat, you get blue dust right away. And that way you know the pigment's up at the top. The other thing that's important to know is higher cross-linking equals durability. Cross-linking is when you take component A and component B, you mix them together, and then they form a hard coating. Well, the more cross-linking with component A molecules and B molecules there is, the more durable the coating, more scratch resistant. And this is an example of a polyester-based polyurethane, and this would be an example more of an acrylic-based polyurethane. The reason that a polyester-based polyurethane dries slower, I mentioned earlier acrylics dry quicker, is there's more molecules in there and there's actually more connections being made, more cross-linking, and that's why a polyester takes longer. So you'll hear people say, oh, that paint dries too slow. Well, the reason is it's curing. It takes longer to cure because of more connections. The other thing that you'll hear about out there is single-stage paint versus base coat, clear coat systems. Typically, single-stage is your Matterhorn white, your cloud white, where you apply a couple of layers of paint, it dries, and that's your finish. Base coat, clear coat is a system where you apply a color, it dries dull, and then you apply a clear coat over the top, and that's where you get your gloss. There are actually advantages to both systems. With a single-stage system, you can brush it. With a base coat, clear coat system, you can have a metallic that basically, where you, with a base coat system, you spray your metallic, and it dries quickly. Those metal particles we talked about dry quickly, and they dry dull, and then you apply clear coat on the top of it. That's how you can get your special effects. With the other system, where you're doing your single-stage coatings, you just apply 3 coats and you're done. So the next thing we wanted to talk about is care and maintenance. And then we'll be close to wrapping this up. Somebody asked me earlier during one of the breaks, they said, do we recommend waxing a boat? And I said, well, wax is a good thing because it acts like sunscreen. But if you ever tell the crew on a boat that's about 200 feet long that they have to wax that hull, they'll throw you off the boat. So what we see is the larger the boat, the less often it's going to be waxed, the more often it's going to be painted. There are areas on the larger boats that get repainted much more often than a smaller boat. A 30-foot contender is probably going to wax their hull on a regular basis, but a large boat like this, they won't. The other thing to remember is a wax or a polymer sealer is typically only going to last about 90, maybe 120 days in Florida. So you might wax that hull and you put it in a slip, and it's not going to last for a period of 12 months. But there are areas of the boat up top on the sides of the boat where if you can maintain them properly, you can wax them, you will get a longer life out of the paint job. Again, it's not with our paint, and with some others, you don't have to do it, but it does help. Some of the things we see with the care and maintenance is that with proper care and maintenance, we can extend the life of the paint. With improper care and maintenance, we ruin the paint. you'll see people out there that are detailing boats, like in this example here, that are using a white wool pad. Well, if you ask 3M about the white wool pad, they tell you that's for gel coat only. The fibers in that white wool pad are too coarse for products like Finesse It or other mild polishes to polish out the surface. So if you use a white wool pad like this on a polyurethane paint like ours, you're going to ruin it. What will happen is you'll see swirl marks down the side of the boat. Now, you might not see them right away because when they polish the boat, the actual polish itself fills those swirl marks. But over a period of a month, 2 months, 3 months, all of a sudden you start to see all these swirl marks down the side of the boat. Typically, that's from using the wrong product on the finish. Today, we have products like foam pads and better compounds. We have 5,000 grit sandpaper. All those things help repairs. It also helps to minimize the scratching on the surface. This is an example here that we see sometimes where crew will actually dip over as they're coming in and scrub the soot off the transom. We'll actually dip the brush into the salt water and then scrub the transom. If any of you have ever put your hand in salt water, rubbed it on your skin, salt water is abrasive. The worst thing you can do is to actually scrub the surface of that boat with salt water because you're putting fine scratches in it. And then all of a sudden the transom soots up more, and then everybody's complaining, well, the transom's sooting up more frequently. And it's a perpetual thing that starts as soon as you get these scratches in the paint job. Now, you need to think about that. The operators of the boat need to think about it. There are ways to minimize this. You could clear coat the transom, and clear coat will help minimize that. But this is just another example of how that can ruin a paint job. And the other thing, just wanted to mention is if you are polishing out a boat, which whether it's gel coat or paint, typically at some point it would get polished because you have two choices. You can polish it and extend the life of the paint, or you can repaint it. We prefer repaint because we sell more product that way. But if somebody's going to polish it, they need to use the mildest products possible to achieve the job. You never want to start with Super Duty rubbing compound. You don't want to put deep scratches into the finish. You want to use something mild. We actually have care and maintenance instructions, like most of the paint companies, as to what to use. We don't have one product we recommend. We have a bunch of different manufacturers like Meguiar's and 3M. But more and more people are trying to extend the life of their paint by polishing. And it's very important for everybody to know that they need to use the right things. And every marina you go into, you see somebody doing something a little different. There's not a lot of structure when it comes to, or standardization when it comes to this type of service. So we kind of gave you an overview. You know about paint now. You know about a little bit about care and maintenance. Wanted to try and keep everything on schedule a little bit. So do you have any questions that we could address?
It's paint. There has to be a lot of questions.
Yeah, there's a lot of controversy with paint. So, yes, sir.
I actually have 2 questions.
Here you go.
I was recently speaking with one of my customers up north, and he had his boat painted about 5 years ago. I think they either used All Craft 2000 or All Grip, and the boat doesn't look that great anymore. It never comes down to Florida. It spends 8 months in a shed, and his paint guy said that the cold weather is actually worse for the boat in the winter up in New England than the UV rays. It sounds kind of strange to me. Does that have merit?
Well, certain things with cold weather, like for instance, we've seen a lot of situations where when the boat is shrunk wrapped with plastic, that'll trap moisture against the surface. I don't know if that would be a situation, but with polyurethane paint, whether it's ours or All Grip, All Craft 2000, the polyurethane will allow moisture to go through it, and it can't come back out. You've all seen examples of this, like, for instance, in a cockpit freezer, when you lift the lid and you see blisters around the edges. That's where moisture's gone through the coating and can't come out. In cold weather, you can run into a situation like that. Typically, UV light is the major contributor to loss of gloss. But if it's gross loss of gloss, like within a year, it could be moisture. But if it's 5 years and the finish isn't looking so good. Can't really say. Maybe they should. That's a difficult one. You had a second question though, I believe.
So the second question is, you never see anything. All boats are using magic erasers all over the place to clean, and you never see any warnings against using them on the paint. But I saw one of my customers has a flag blue hull, and you can see where the crew went along, cleaned off scuff marks from fenders or whatnot, and there's a mark everywhere they use the magic eraser.
Magic erasers are a great cleaner. I have magic erasers in my house, but I will not use it on my paint job. There are chemicals that are basically acidic that are great for cleaners, and they'll ruin paint jobs. You need to be very careful. If with something like a magic eraser on scuff marks, I wouldn't recommend that. I'd much rather see a product like Finesse-It used by hand. Finesse-It's not strong enough to ruin the paint job, but it will polish out some of the fender wear. If you run into a situation where you're getting a lot of water spotting, things like that, the best thing to use is warm water and vinegar. That's an old trick, but a lot of people use that. As far as magic eraser goes, that's a great example of a company's developed a cleaner that they developed for all kinds of things for household use. Somebody tried it on a boat, and then all of a sudden, that develops problems. So as far as a paint manufacturer goes, we try to test some things like that, but we can't test everything. But I would not use magic eraser especially on a dark blue boat. That's a problem. I don't know if that answers your question or not, but hopefully. Yes?
Hey, Tripp. Is there, with the heat in the dark paints, it's a real problem, especially when you're talking about the masks on sport fishing boats. Is there any experimentation or research being done with things like nanotechnology that can dissipate heats and still maintain those dark colors?
There actually is. That's a great question. In some of our other markets, we supply a pigment that doesn't absorb the heat. If you and they exist in nature. I mean, actually, if you go out on a hot summer's day and you lay down on a grass yard, it's dark green and it's not hot. If you went and put your hand on a painted surface that was the same color as the dark green grass, it would be warm to touch. And that has to do with the pigmentation. What we found is that we can only produce a very dirty brown pigment with that technology at this point. And, we buy our pigments from the same companies that AkzoNobel and Sherwin-Williams and PPG buy their pigments from. So we all are buying products from the same suppliers, and then we cook them a little different. And that's how we each come up with our own formulas. But today's technology doesn't allow us to get a real clean flag blue. It would be a sort of it would be a tannic acid stained color.
So for now, we should soften this.
For now, the mask situation is basically you could use the metallic, which helps, but that's just a 20% reduction in surface temperature. So,
any other questions? Tripp and Jeff, that was great.
Thank
Thanks
you.
so
We'll
much.
be around
Let's hear it for these
afterwards.
guys.
So.